In this video we will be talking about group 1 alkali metals. In the previous video we looked at the whole periodic table and how elements are arranged in order of atomic number. We also looked at the columns, which are the groups, and the rows, which are called periods, but in this video we'll be looking at the group 1 alkali metals in a bit more detail. The reason why they're called alkali metals is because these metals react with water to form alkaline solutions. So these group 1 elements, the alkali metals, are the most reactive metals that occur. Depending on how reactive they are, they can spontaneously ignite and burst into flames just in oxygen in the air. They also react vigorously with water, and they can ignite and burst into flames. So these elements, these alkali metals, are actually stored in oil. Now the reason why they're so reactive is because they have, remember they're in group 1, so they have one electron in their outer shell. So what they do is they get rid of their one electron that they have in their outer shell. And because it's so easy for them to get rid of that electron, it makes them very reactive. Now there is actually a trend in the reactivity of these alkali metals. A trend is basically a pattern in a specific direction. So the reactivity of the alkali metals increases as you go down the group. To understand why these elements become more and more reactive as you go down the group, you need to have a look at the electronic arrangement of the atoms for these elements. So here are the electron arrangements for the first 3 elements in group 1. We have lithium, sodium and potassium. You can see here they all have one electron in their outer shells because they're all in group 1, and to get a full outer shell they all get rid of their outer electrons. So why does the reactivity increase? Why is potassium more reactive than sodium? Why is rubidium more reactive than potassium? So the reason that is because as you go down the group, and you can see here from the electron arrangement, the atoms get larger and larger each time as you go down the group, and they gain one extra shell. So lithium has 2 shells, sodium has 3, potassium has 4, and that's linked to the period number they're in. So potassium is in period 4, sodium is in period 3, and so on. So the number of electron shells increases down group 1, and this means that the outer electron becomes further and further away from the positive nucleus. Remember, there is an attraction between the positively charged nucleus and the negatively charged outer electrons. Therefore, the weaker this attraction is, the more easier it is to lose that electron. Another thing to remember about these group 1 elements, these alkali metals, is that when they react they form a 1+ ion. The only difference between an ion and an atom is that atoms are neutral overall, ions have a charge. Okay, so all of these atoms are neutral to begin with because they have the same number of protons and electrons. Protons have a positive charge, electrons have a negative charge, so those positive and negative charges balance and cancel out because they have the same numbers of those each. However, when they react, they lose electrons, so they have less electrons now. So overall they have a positive charge. And that positive charge is +1, 1+ charge. So for example, this is the electronic arrangement for sodium. When it reacts, it gets rid of this electron and forms a 1+ sodium ion. Okay, and we draw the electron arrangement like this. We draw brackets around the ion and we show the charge outside the brackets to say that it's got a positive charge due to the loss of electron. You don't need to draw this circle and arrow, I've just drawn it here to show you that this electron is being lost. You can also write this as an equation. So we have sodium to begin with, it's neutral, and then it forms a sodium ion. It's got a plus charge because it's lost this electron. So sodium, arrow, sodium plus ion, and an electron. Now I would like you to have a go at doing the same diagram for potassium and also this equation here. So pause the video and have a go. Okay, so this is what you should have. This is the arrangement for potassium before it loses an electron, and then it loses 1 electron, so it's got a full outer shell, and we put those brackets around it with a 1+ to show it's got a 1+ charge now.